Okay, so now chapter 6 is basically focuses on the different functional forms. The first functional form that you observe is linear functional form. So the form of this linear is basically y is equal to beta 1 plus beta 2 x. So if I find out the slope, all that I have to do is to differentiate y with respect to x. How do I do that? I would total differentiate on both sides, so this becomes dy. The differentiation of beta 1 would be 0, beta 2 is a constant, and the differentiation of x would be dx. So I would get dy by dx equal to beta 2. So this is what I have done here to get the slope. Elasticity of anything is given by x by y is equal to dy by dx. So I multiply dy by dx with x by y, and I get this as the formula. Okay. So now what is its interpretation? Beta 2's interpretation. So beta 2's interpretation is that if I change x by 1 unit, then y on an average, this word is very important, average. So if I change x by 1 unit, then y on an average would change by beta 2 units. So just see this, I can see it through the slope, that if I put dx, which is change in x equal to 1, then dy is coming to be beta 2. So if I change x by 1 unit, then on an average y changes by beta 2 units. So if I come forward to the next model, it talks about the log linear model. So basically this model says that it's linear but in log. A very important speciality of this model, which I will very soon highlight, is that the elasticity of this model is actually beta 2, which is a constant. So this is a constant elasticity model, and you can actually compare that in which of the cases, in which goods you actually get a constant elasticity. Alright, so it's basically linear in log. So I have a model as ln y equal to beta 1 plus beta 2 ln x. For the slope, I would total differentiate again on both sides. So I would get 1 by y dy is equal to beta 2 1 by x dx. I would as a result get dy by dx is equal to beta 2 into y by x. If I have to find elasticity, I would multiply the slope with x by y and get beta 2. So now a very important thing that I have to do is to find the interpretation of beta 2. So basically whenever you would see log, I would be actually talking in percent terms. So what beta 2 says is, if x changes by 1%, then on an average y changes by beta 2%. Another way to see this is that, so if I see this, what do I get is beta 2 is relative change in y due to relative change in x. And how do I get this? How do I know this? So just see, if I have to find out beta 2, what is beta 2? Beta 2 is dy by y upon dx by x. So it's relative change in y due to relative change in x. Coming to the next model, I would be talking about log ln model. So I have ln y equal to beta 1 plus beta 2 x. To find the slope, I would again total differentiate on both sides, and I would get 1 by y dy equal to beta 2 dx. From here you get dy by dx is equal to beta 2 into y, and the slope becomes, if you see, beta 2 into x. So you can clearly see that in this case I do not have a constant elasticity thing. Now if I have to find out the interpretation, then you can clearly see from here that beta 2 is dy by y upon dx. So it's relative change in y upon absolute change in x.